My name is Fershad Irani from the Green Web Foundation, and today I'll be speaking about the nuance of quantifying digital carbon emissions. Just really quickly, a brief introduction of myself. I'm an Australian living in Taiwan. I've called Taiwan home for the last 11 years. I'm the maintainer of a JavaScript library called CO2JS, which allows JavaScript developers to really quickly start to implement carbon emissions estimates into their products and the stuff that they're building. I'm also the creator of a website testing tool called Are My Third Parties Green, which aims to surface information about the different third-party scripts that websites use these days more and more, especially information about whether those scripts are served from green web hosts or from non-green sites. And finally, I do that work and a lot more as part of my role as a developer and consultant with the Green Web Foundation, which is a Dutch non-profit that's working towards a just, sustainable, equitable, fossil-free internet by 2030. We do this through open source, open data, and in general, fostering an open culture, not just in the work that we do, but with the people and the organizations that we work with. Just really quickly, the Green IO podcast was the first ever podcast episode that I recorded, and it was also the first time that Gail recorded Green IO, and it's fantastic to see the growth of Green IO as a platform, and having Green IO Singapore, the first event of its kind in Asia, is fantastic as well. Over the next short little while, I'll be going really quickly through a few different topics. Unfortunately, we can't go in depth into a lot of them. There is a lot more that we could cover if we had more time. But we'll be talking about the emerging reporting requirements that we're starting to see around the world, the difference between estimating and measuring, because that's really important to understanding what you're doing. And then we'll walk through the tech stack to see what different tools are available to us for both estimation and measurement. Let's get started, eh? So we're beginning to see more and more countries legislate reporting requirements around carbon emissions and ESG and other related areas. Two examples of this are in Europe, the Corporate Sustainability Reporting Directive, and in California, the Climate Corporate Data Accountability Act. Both of these are, I believe, coming into effect from next year, and they set really clear guidelines for companies around what they need to be reporting for carbon emissions and other ESG related issues. We will see more and more countries putting legislation into place in the coming years, and I think it's going to be really clearly mandated for organizations that are operating in those countries what their requirements will be. Another thing we're starting to see, though, is guidance from regulators for publicly. Another thing we're beginning to see as well, though, is regulators starting to offer guidance to publicly listed companies around upcoming reporting requirements that they will be required to fulfill. Two recent examples of this come from China and the United States, where the securities commissions in both those countries have put out guidance about upcoming reporting requirements that publicly listed companies on those exchanges will be required to meet. Now, there are some key differences in how these two bodies are going to be requiring organizations to report on, and so we're just going to walk through those really quickly now. In China, the Securities Regulatory Commission has put out guidance that says that organizations that are listed on several of the stock exchanges there will be required to report on Scope 1 and Scope 2 emissions. Now, these are the emissions that those organizations generally have more control over. But they'll also be expected to report on Scope 3 emissions. Now, these are emissions that are harder to control for an organization because they relate to your supply chain and also relate to the use of your products and other downstream implications. So companies in China are going to be asked to report on the whole three scopes of their. So companies in China are going to have a more rigorous reporting requirement around what their regulator is required. So companies in China are going to have more rigorous reporting requirements passed down from their regulators, especially if they are publicly listed. Meanwhile, in the United States, it's going to be a bit different. The regulator there is requiring Scope 1 and Scope 2 emissions, the same as China. However, Scope 3 emissions are a bit grayer. So in the United States, listed companies will be required to report on Scope 3 emissions if those emissions are, let me just check the notes. So in the United States, publicly listed companies will be required to report on their Scope 3 emissions if those emissions are material, or if they have net zero goals or climate reduction, or if they have emissions reduction goals that are based around Scope 3 emissions as well. Now, this is really important in highlighting the difference that is going to be present when listed companies in China and listed companies in the United States are reporting on their emissions, because Scope 3 emissions make up a significant portion of a company's overall emissions profile. In this slide, we can see Google's latest environmental report. So this data is for 2022, showing that 75% of Google's total emissions were attributed to Scope 3. You can see here the different categories that Google covers for their Scope 3 emissions. One interesting note is that category 11, use of products sold, includes Google's flagship hardware products, but it does not include software products like Google Chrome, use of Gmail, etc. Now that's really interesting, because when you compare this to Mozilla, who in 2019 released their greenhouse gas emissions baseline, they found that Scope 3 emissions made up 93% of Mozilla's total emissions profile. Now, obviously, Google, Mozilla, companies of very different size, very different scale, but you can see here the Scope 3 emissions categories are pretty similar. What's interesting to note here is that Mozilla, in their reporting, included Firefox desktop use, Firefox mobile use, Pocket and Mozilla Hubs included in their Scope 3 emissions. It's really interesting that they did this, because some of the work that was required for them to start to quantify the carbon emissions from the use of something like Firefox desktop led to them introducing some really useful tools into the Firefox browser. Some of those tools we'll talk about later in this presentation. I bring that up because it would be really nice to see Google Chrome, given the market share of that browser and also Chromium-based browsers in general. It would be really nice to see that type of tooling being introduced into Google Chrome, and it would allow Google to perhaps start to report on Scope 3 emissions from the use of software as well. So I hope this has kind of painted a picture for you about what the reporting landscape might start to look like in the years to come, and also why Scope 3 reporting is going to be so important in this whole piece. Now, I really quickly just want to touch on semantics, because you'll notice in the title of this talk, I've used the word quantifying. I've not specifically called out estimating or measuring, because I want to talk about both. I often see people confuse estimation and measuring, and so it's really clear to understand the difference between them, and when you are estimating and when you are measuring. So let's start with estimation. It's imperfect. It relies on models. Now, these models often contain a number of assumptions. They use average figures. They might have other things baked into them which will impact on the results and the accuracy of the results. They are not going to be 100% accurate, but they might get you close to a ballpark figure that will then help you assess your carbon footprint. What's really important to note is that these models are easier to get started with. So they are a very good entry point for folks that are first coming to the area of carbon emissions estimation, or that have been asked to in some way quantify the carbon emissions of their digital operations. There are two types of models. You've got top-down models, which kind of look at a whole system, a whole network, and then use averages based on that to form the overall model. These are more lightweight, they're a lot faster to use, but they're more likely to overestimate the emissions in their results. On the other end of the spectrum, you've got bottom-up models, which look at individual components of a system and then attribute different values to those. They're more detailed, they're far more focused on accuracy, but as a result, they're more likely to underestimate the emissions of a system or a network. Now, there's a lot of middle ground between these two. Some models fall more on the side of bottom-up, some fall very much on the side of top-up. Sorry. There's a lot of middle ground between these two. Some of these models fall very much at the side of bottom-up, others fall very much on the side of top-down, but it's really important to know when you're using one, when you're using the other, just because of how it will impact on the results you're seeing. And that's super important because we like to say in the foundation that all models are wrong and some are useful. Now that's really important because, as we like to say at the Green Web Foundation, to quote George Box, all models are wrong, some models are useful. It doesn't matter if you're using a top-down model or a bottom-up model. You just need to be cognizant of how those models are impacting the results that you're seeing, so that then you can talk to those results. You can be more confident in conveying what they mean to other people who might be asking you questions about them. If we look at measuring now, measuring is an exact science. It requires a lot more tooling, setup, and knowledge to get started. One of the ways you can get started with measuring is plugging a smart plug into your wall and then connecting your computer to that. That will then start to give you information about how much energy the computer is using whilst it's performing certain tasks. However, all that tooling takes a lot of setup, a lot of knowledge. There's a lot of technicality involved in this. It might also require you to take multiple steps to reach a carbon emissions figure from that measurement. You'll start with watts of power being used, and then you'll move to a carbon figure. Along that way, you're going to have to do some conversion and calculations. So you need to know what that looks like. As a result, there's a steeper barrier to entry for measuring. However, of course, the results you're getting from measurements are exact and precise. So they are preferred if you can get your hands on them. So now that we've covered a bit about that nuance between estimation and measuring and trying to be clear about when we're doing one and when we're doing the other, let's go through the stack and see what tools are available for measuring and estimating the different parts of our technology stacks. We normally talk about system segments when we talk about measuring or estimating the energy or carbon of digital services, and these are broken down into three segments: the data center, the network, and user devices. For this presentation, we're going to go from devices back down to the data center, and we're going to talk about the front end first. This is a website which I'm sure some of you have visited, websitecarbon.com. It's the original website carbon calculator, as the marketing copy on that webpage says. It's one of those tools that really has started to get digital emissions into the public consciousness, and that is a really good thing. But what's important is that we understand what is behind the figures we see when we run a web page test through this tool. So Website Carbon is based on an emissions estimation model called Sustainable Web Design. Now, the Sustainable Web Design model covers all three of those system segments we talked about just then: data centers, networks, and user devices. It uses data transfer, so megabytes or bytes transferred over the network, as a key input for all three segments. There is another input which is green web hosting at your data center, but the key input for the entire model is data transfer. And this is somewhat controversial, which we'll touch on shortly when we talk about networks. It also includes a number of assumptions. Now, these assumptions are key to It also includes a number of assumptions, and it's important to know about these assumptions because they do impact the overall result that we're seeing. It includes assumptions about the amount of data that is reloaded when a user comes back to the website. It also includes assumptions about website visitors, what percentage of visitors are new to the website and what percentage are returning. It also uses a global average grid intensity figure when coming up with their carbon emissions, the final carbon emissions result. Now, this will impact the site's results because you might be operating in a green area, somewhere like Norway, where the grid is far less energy intensive than somewhere like where I am now in Taiwan. That definitely does play a part in the results you'll see. One important thing to note with this methodology is that you can swap in actual measurement figures for each individual segment if you have them. So for example, if your data center provider has given you information to say, hey, this is how much carbon emissions your website has produced in a year, you can then take that figure and work it down to a per page view value, and then put that into the results that you get from the sustainable web design model, and use the model to estimate the network and user device components of the systems. Now that just helps you get to a bit more accurate result, which is really what we want to see when we start to do carbon estimations and start to refine the estimates that we're doing. In terms of front-end estimation, there are a few other models and methodologies that we're starting to see emerge. One of these is DIMPACT, which is for digital media and entertainment. Now, I've seen DIMPACT also be used to measure the emissions of an online event, which is really, really cool to see that you can go into that much detail using a model for estimation like that. DIMPACT also covers all three of those system segments we talked about earlier. Another model for measuring front-end emissions is GreenFrame. Now, it's the device segment only, and it's limited to websites and apps. But one thing that GreenFrame has that other models don't is the ability to script user behavior and measure the impacts of those user behaviors. So if you want to test an individual feature and how the emissions for that might look on the front end, you can write a script for that to run through GreenFrame and get those results. And another one that we've noticed is Scope 3, mostly used for digital advertising, but you can also use it for websites and streaming and some other things. It again covers all three of those system segments that we covered before. Now, it's worth noting that while these methodologies and models are largely open source, parts of them are used by some of the agencies and groups that have created them as part of paid products that they sell to customers. So it's just worth keeping that in mind. So we've talked about estimating on the front end. Measuring on the front end is a bit more difficult. One of the ways I mentioned earlier was plugging a smart plug into your wall and then measuring how much energy your device is using. That's one way of doing it. An easier way to get started, though, is through the Firefox Profiler. The Firefox Profiler is a tool that allows you to capture a screen recording, a recording of someone using a web page, and then gives you a whole bunch of diagnostics about that use of that page. I mentioned earlier that Mozilla had done some work to try and quantify the carbon emissions of Firefox desktop use, and this is one of the things that came out of it. The Firefox Profiler now allows you to get energy and power consumption figures for a given recording. We worked with the Mozilla team last year to then include carbon emissions figures as well. So you now get power, energy, and CO2e values when you do a recording on the Firefox Profiler. The Firefox Profiler, it's worth noting that this tool is not yet able to be fully automated, so you'll have to manually run these tests, but it is a super, super good way for quality assurance and product teams to start to baseline the front-end energy use of their apps or features in their product, and then see how over time different additions or changes to those might impact the energy profile of that feature or product. One thing to note is that the results you'll see from the profiler vary in detail depending on your operating system as well as the CPU chip that you've got running. But again, I strongly recommend folks give this a look because it's one of the few tools that make it really easy to monitor, to measure front-end carbon emissions and energy use. Moving on to the network, this will be quick because measuring on the network is super hard, so I'm not going to cover that. We're going to talk a bit about estimation approaches that are on the network though. There's a bit of conjecture about some of these. So data transfer, I alluded to earlier in the sustainable web design model. It's a bit controversial. It's an attributive top-down model, so it looks at the whole network and then uses figures like the total energy use of a network divided by the total bytes that are transferred on that network to come up with a value that's then used as part of the emissions estimation calculation. It's widely used because a lot of previous research was based on this. However, there's a lot of strong debate in research circles as to the validity of using data transfer for measuring network emissions going forward. Another approach we're starting to see more and more of is duration and bandwidth-based approaches. These are more predictive. They're bottoms up, so they look at individual components of a network and then attribute certain values to those. They normally will attribute a baseline power consumption, so a flat power consumption that's always used by those devices or by those network components. And then there'll be a variable amount on top of that, which is often based on how much data is transferred. And this leads to some assumptions having to be made when you're using such approaches. For example, on fixed networks, you need to make assumptions about how many users or devices are on a given network so that you can attribute that baseline power accordingly to those devices. So again, network is super hard to measure. In the estimation space, there's a lot of debate at the moment. It's something that I think we'll see really shake itself out in the next year and a bit, and we might get to a good place with solid estimation models around the network component by then. And finally, data centers. That's the last piece of our puzzle. Sometimes you'll get this information from your providers. Amazon, Google, Microsoft, they all provide carbon emissions dashboards that their users can view. However, they do lack a lot of detail in terms of time sensitivity, so they're not really granular. Some of them are quarterly, some of them are monthly. It'd be really great to see hourly based reports, but we're not there yet. There's also a lack of transparency about how the values are calculated or how they come up with them, which would be really good to see them being more open and transparent about this. If you are looking for something that's a bit more granular than what is being offered by your cloud provider, a tool like Cloud Carbon Footprint is an open source public methodology. It's got a very nice dashboard that you can install and use. It connects to AWS, Google, Azure APIs to get information about cloud usage. It also, which is really nice for us in the Asia Pacific region, connects to Ali Cloud as well, which is fantastic. I don't think there's other tools out there that do that at the moment. Being open source as well, if you are able to get information from an API through your cloud provider, if you don't use one of those big 3 or 4, you can then extend Cloud Carbon Footprint to work with your cloud provider. That's one of the values of it being an open source tool. Another tool, and I came across this recently, so I can't speak too much about it, is OpenCost. It's again an open source project run by the CNCF. It was originally built for Kubernetes cloud native monitoring and working out the carbon costs around that. Recently, they also announced a collaboration with Cloud Carbon Footprint, and they are really looking to expand beyond just the Kubernetes cloud native space. So OpenCost is probably one to keep an eye on going forward. And finally, if you want to measure the emissions of your data center, that gets a bit harder, but you can use a tool like Scaphandra. There are a few others out there, but I want to shout out Scaphandra. It's again open source. It works on bare metal hosts, certain virtual machines, and also Kubernetes, but it requires a lot of technical knowledge to set up. You need to have access to the box itself or have admin rights to be able to install it and run it and get it to be producing the reports that it can produce. But once you're able to get it set up, the measurements of power and energy consumption and the reporting that it can give you is super, super detailed and really, really fantastic. So definitely a tool worth checking out if you are able to have access to those boxes where you can install stuff like this at your data center. Now, I'm going to stop there because I'm running out of time. If any of these ideas or things that I've spoken about interest you, please do get in contact with us at the Green Web Foundation. We do talks, workshops, training, consulting about all this stuff and a lot more at the intersection of climate change and digital. We do talks, workshops, training, consulting about all this stuff and a lot more. So as a non-profit, the work that we do here helps keep us afloat and helps allow us to give back to the community through some of the open source projects that we maintain. You can contact us on LinkedIn or find us at our website, thegreenwebfoundation.org. I myself am at fershad.com, also on LinkedIn or Mastodon, where you can find me. Thank you for your time, folks. It's been a pleasure talking to you.